Hello, my name is Rudy Mannarino. I'm a sound designer with One Sound, and I'm here to show you our brand new analyzation software called Auralis. Auralis is a 3D design software made from scratch by One Sound. It's a very powerful tool that you could use in your designs using One Sound as sources, and could offer you a lot of different tools and measurements to help you with your designs and projects. It offers things such as time alignments, delays, SPL maps over surfaces, phase responses from the sources, mechanical information, and aiming info. And it could also print out reports, snapshots, things that you could show your team, show your clients, different concepts you could have, and different designs to give them something physical that they could see of what One Sound may look like in their space. So let's get into it. Okay, so we're going to start off by going through the different options that Auralis gives you. If you open up this top left tab here, you could open up a new project here. You could open up a pre-existing project. You could undo, redo actions. You could also do this with hotkeys like Control Z or Control Y. You could save a project. You could import a 3D file or a 2D image. You could export different types of reports. We're going to go through these two options later. For now, we're going to go into the preferences. Here you could change between metric and imperial. If you have a 2D file you want to import and you want to scale that file to a surface and you only have the measurement in metric, you could do that. You could start in metric and you could change the feed afterwards, and the surface, the project, it'll convert and scale. So don't think you're stuck to one option here. You could change this at any point. The calculation tab will give you weather conditions, which might change the characteristics of the sources. You also have SPL calculation preference. This will give you an SPL calculation at a specific frequency or at a specific frequency range. So you could change that here. In the Workspace tab, we have Snap to Grid or Snap to Object. For now, I have Snap to Grid, so when I'm moving these surfaces, they're not snapping into each other as I'm moving them. But I might change the Snap to Object later as I'm moving, different speakers or sources. I want to have a smooth mouse drag and put them in specific places, so I'll change the Snap to Object later as I'm doing that. Next, we have project information. This is where you could put all the details of your design and the project. This will export to all the reports and could give a nice clean look and details into what the design is and what it's consisting of. Next, we have the Help tab. This pulls up the Auralis manual. And we also have the Info tab, which gives you the software version. So you could make sure you're up to date on what software update we're using. Over here, we have Viewing tabs, and this will turn on and off the different axis, grid, and trajectory values. So if you turn this on and off, this will change the X and Y axis to be on or off. This will change the grid on and off, and this will change the speaker trajectory on and off. This option, World Local, gives you an X and Y axis based on the tilt of the speaker. So you could change this to be in line with the X or Y axis or in line of the tilt of the speaker. This tab over here gives you snapshots for your snapshot report. So you could actually take pictures of the design and then you could later export this as a snapshot report, and you could change the viewing angle of what pictures you want to take. Now I'm going to go over the different types of surfaces that Auralis offers and how to import them into your workspace. We're going to start off by importing a plane. These are all the different surfaces that you could import, but for now we're going to work with a plane. You can move it by dragging the arrows or the little boxes in the surface. This green arrow will drag it along the Y-axis, the red one the X, and the blue one the Z. This box on the bottom will move it along the green and red or the X and Y axis. This top box will move it along the Z or Y. And this middle box will move it anywhere in the 3D field. Over here, you could change the name of the surface. You could lock the surface from being moved. You could change the visibility of the surface. Or you could change the audience area on or off to show the SPL map on or off. This audience value will give the height of where the audience is listening, and this will change the SPL measuring when you do start using the SPL Map feature. So you could change if they're sitting or if they're standing. This mirror X feature will mirror the surface on the opposing axis. You could change it from X or Y. These values will allow you to specifically change the values of where you want the surface on the axis. This will change the tilt given on that axis of the surface itself. So we could change the tilt to 20 degrees. This will change the Y tilt. And you could get more specific on the angle of the tilt. And on the plane surface, you could see how all the different points are moving at once. That's because on the plane, you could only change the width and the depth of that surface. If you want to change the individual values of each corner, you would have to choose a polygon. Now we could import a polygon surface. This is similar to a plane, except you could actually change each different point to make a custom surface. So let's say we wanted to change these outer edges. We can move this one out toward the negative side of the x-axis. We could even tilt it up if we want. Let's change this one to be even longer. So now we're going to import an extrude surface. This surface is great to use if you have inclined seating. So these values over here, this number 1 will change the vertex of the surface. So it'll change these 2 points essentially. Number 2 will change these 2 points, and number 3 will change these 2. So let's say we wanted to make the whole surface wider. We'd go into this value here, and we can make it 45 feet wide. Let's change the audience area, so maybe that first plane's a little closer to the stage, or a little over the x-axis, a little longer. If we change this height value, we'll actually get a decline. So let's say we wanted to add another incline angle and another plane. We could do that by pressing this value here. Let's make it a little taller than the previous plane and a little longer. So now I'm going to import a Revolve Surface. This surface might be great to use if you're designing an arena or a dome-shaped audience area with multiple different planes. Over here, we could change the angle. This will change the radius of how far it comes out. And this first setting is just like the extrude. It'll change the surface along these inner circles. This vertex will change the outer circles. We could also add more as we go. So if we want to make this outer portion maybe taller and longer. So here we could add more points along the radius. And here we could add another plane of incline. So this is how you could import a 2D image into your Auralis workspace. We're going to go to the top left again and go to import. I have an image on my desktop. You might not be able to see it, but I'm going to select it now. So when you import the image, you'll get this measuring tool. I don't have any measurements here. I found this file off Google. So it didn't give me any measurements, but we're going to take this door and assume it's going to be 3 feet. So you want to just line up these little boxes, and the center of it is going to be that center point of where that measurement begins. So we're going to add the image, and it pops up in the middle of the X and Y axis of your Auralis workspace. The first thing I want to do is make a surface so I can measure the SPL map as an overview of this image. So we're going to select a plane, and we're pretty much going to copy the depth and width of the image and just copy it over to our plane. All right, and then we want to go to our plane and make sure that it's in line of the X and Y axis. We could go over to our image and set the opacity so that we could actually see our surface. This way, when we do the SPL map, you could change how vibrant you want those colors to be. Now that we have our 2D image file overlapped with a surface, we're ready to start placing in sources to maybe cover the areas that we want to cover. And we could place in sources by going to Design, Speaker. Auralis gives us a few different options to import into the workspace. We could place in column array sources, we could place in point sources, a single sub, a subarray, and we could also turn these into groups, which we'll do in a little bit. But for now, we're going to try to cover these 9 tables here with C6s. So to do that, we're going to want to place a point source. When you place a point source, it comes in on the 0 of the X and Y axis, and it gives you a few different options on the left. We could name this C6, and I'll give it 1. We could change the model of it to a C6, and then we can move it freely to where we want it. So we maybe want to cover these 3 tables here. So I also changed my preference settings to snap to object, so I could move and drag freely instead of the source snapping to each individual grid. So looking at the speaker, we can see that the front of the speaker is facing toward the outside of the wall based on this yellow line. So we want to move that and change it 180 degrees to face inside toward the table. So we could do that here. We could also change the height of the speaker. And this height is going to be the middle of the speaker. You could see that by going to the mechanical view, and it'll show you exactly where that speaker is in terms of the height and how far it's coming off the wall. This could come out in a report, and you could export actually every speaker, and it'll show you how high it is and the dimensions of the speaker. So we're going to go back to design. And if we want to change the angle a little bit, we could actually use our arrow keys instead of inputting it, which might be a little faster. But for now, we're going to keep it 180 degrees facing this table. And we could see that it's pointing straight out. So we might want to give this source a little bit of an angle to face toward the tables. And we could do that here. Let's give it a little more of an angle so it hits that first table right below it. If the speaker has any presets, we could do that here, but this just has a standard preset. We could also change the gain of the speaker. So right now we have C6.1. Let's duplicate this by right-clicking and duplicating the C6 and move it over to the second row of tables. The duplication happens right on the speaker, so you could just drag what's selected. It'll be selected default to what you copied. And let's take another speaker, duplicate it from the one we just did, and move it to this table here. So now all 3 rows of tables have a C6 lined up. So now that we have our C6s placed in the areas that we want them to cover, we could see how the C6s are reacting in this space. So we're going to go to our SPL Map feature. We're going to click on that, and now we get a reading of the SPL measurements over the surface. If you go to the top right, we could change the values of what we want our targets to be. So we're going to change our logarithmic scale of our dB scale to dBA, SPL Map on auto, and that kind of gives us a good range of what the SPL measurements are based on the scale that you're using. So dBA is a little lower than dBZ, and custom dBZ will be a little lower than a full range scale like dBZ 20 hertz to 20 kilohertz. So the auto function is really great to use when you're using different scales. The isobar map is a great tool to use as well because it gives you the measurements in 3 dB increments. So let's go back to DBA and try to see if we could fill out this area that we want the best we can. Okay, so at 105 dBA, this might be a little too much of a target that we want to hit. So we're going to go to 102, and we're going to see that we have even coverage on these two tables. We're going to try to do that in 2 speakers, not 3, because I think we could do it in 2, so let's try. We're going to inch these 2 in a little more and see if we still get the coverage on at least these 6 tables. So it looks like the tables closest to the wall, these 2 chairs aren't getting that 3 dB range that we want. So we're going to try to tilt these in a little more. And see if we could hit those chairs. Let's move them out a little more. And now we're getting it in the range that we want. But we're still missing these tables, so we're just going to duplicate these sources. And we're going to put them over here. Change the angle. Great. And now we know that all 9 tables are receiving 99 to 102 dB in DBA. Okay, I'm just going to go over a couple of the updated features. So if you go to this button up here, it could switch between perspective and isometric. It's perspective off default, which gives you a more 3D realistic view of the space. If you switch it to isometric, it will give you kind of a 2D perspective. This is nice to use when you're on the Z-axis trying to, place speakers. The speaker won't actually move off of the shadow. It'll always give you a 2D view from the top. You can see how it changes in the perspective view. So it's a little bit harder to pinpoint exactly where it is on the plane. So this could help with that. Another feature is up here. It's a rotate feature. If we click on a speaker, we could rotate it horizontally just by click and dragging. If we click on this H, it'll turn to a vertical angle where we could click and drag the vertical. Another little feature is this click perspective angle viewer, where if you click the face of the cube, it'll show you exactly that perspective in the space. Now we'll begin to go over how to import clusters into your design space. Right now, I have an extrude surface that is 60 feet wide and 80 feet deep with a gradual incline of 10 feet halfway on the floor of the surface. This distance of 80 feet that we need to cover will do well with a stacked line array to allow us to get more even coverage over this farther distance. Our goal will be to cover this total area at 100 dBz. Let's go ahead and import a stacked line array column. On default, the column will import with LCC 44s and a flown configuration. You could change the type of model of speaker here. You could also change if you would like this system to be stacked or flown. Now we're going to move the line array into the position we want. Then we're going to select the height of the line array. We're going to choose 20 feet. 20 feet is the position of the top of the stack. You can double check this in the mechanical tab. In stacked mode, the height will change to the bottom of the line array when you choose your position on the Z-axis. To get us started, we're going to use the auto splay feature to see what Auralis thinks is the optimal positioning for the array. Looking at the array, we're already meeting our goal, but let's see if we could do anything to make it better. That's giving us less coverage in the back rows. And this is giving us more coverage in the back rows. Let's change the amount of boxes by adding one more. When you're done with your array, you could check other specifics in the mechanical tab. You could check the center of gravity, and you could also check what pinpoints you want to fly off of the flybar and what holes to go in. In the cluster tab, we could auto display what decibel targets are good for this cluster, and we could see at a specific frequency what's happening at a certain distance. We could change the frequency, and the SPL graph will change. If we click on a point, this will give us a full EQ curve. Now we're going to cover how to utilize the Acoustics tab using microphones. Looking at our project now, it seems that we will need more of this area covered with sound reinforcement. We will want to check what frequencies are lacking so that we can fill them with sufficient coverage. You can place as many microphones as you need. We're going to place one in front of the cluster and then a second microphone on the opposite wall. Looking at the microphones, we could see that the default position is 4 feet tall. This can be changed based on where the audience is listening from. Knowing this, we can place a third microphone on the back wall at 14 feet because of the incline of the Extrude Surface, which is a maximum of 10 feet tall. Then we can name each microphone. Now that we have placed our microphones, we can view their responses in the Acoustics tab. Here we can see a few different things. We could see the frequency response of the microphone. We can see the phase of each speaker that is being picked up by the microphone. Then we can see the time arrival of each speaker based on the microphone selected. First, I'll explain how to meet our goal achieving a full frequency response suitable for a show using the microphones in Auralis. Comparing the first two mics, we could see a huge drop in decibels, so to fix that, we're going to add a cluster to the right side. Then we'll add a delay fill for the back rows to show off our auto-align feature. And now we see the summation curve of all the sources from that microphone selected. So by selecting the main cluster and the back wall microphone, we could actually auto-align this delay speaker by clicking this button here, and it delayed at 53 milliseconds. If you want to do it manually, there are delay times located on the right side of the page to help you. By selecting different sources, not only will you see the different delay times to the microphone, it will also highlight the frequency response of that speaker in relationship to the microphone. So the delay times are changing here, and it's highlighting the different curves. And the yellow curve is our summation curve. You could click that on off here. You could take the speaker graphs off, and you could bypass the gain and the delay. Okay, so I spent some time and finished this design so we could start learning how to export reports. Auralis offers a professional and intuitive method of creating a document that will allow you to see many different aspects of the design. When you're finished editing the design, it is important to label all sources and microphones as well as the project information because all this info will be included in the report. Now, the first step is to take pictures of the design that you want to display in the reports. So to do that, I'm going to give it a DBZ graphical map to take the first picture of the whole system. You could select your parameters that you want, your different viewing, and we'll take a picture looking at the stage. You could label it here. Next, I only want to show the clusters, so I'll mute everything else. And then next, let's just do the delays. So now only the delays are showing. For the final picture, we're going to do a custom frequency range. So we're going to go over here to calculation, and we're going to do, let's do 2000 to 4000 hertz. Select it down here, and we'll unmute the whole system. All right, now that all the pictures are done, we could choose to export a full report. This will be automatically grayed out if you haven't taken any snapshots, but you could edit the snapshots in here. You could rename them. You could delete them. You can make it visible on the report. You could even put notes to what you're displaying, even though what type of scale you're using will be on the side, what type of dB scale. So there will be other information on here, as you'll see. So let's report everything. The snapshot report will give us pictures of the design, the snapshots we just took. The microphone report will give us the frequency range of what the microphones are picking up that you put in the design. The speaker list report will give a list of all the speakers that you're using in the design. The deployment report will give things like gain, delay on certain speakers, and the position of them on the X, Y, and Z graph axis. And the mechanical report will give things such as downward angles, what holes to go into when you're hanging. It'll also give heights and dimensions of each speaker. So we're going to create this report here. This is what the report looks like. First, it starts out with the snapshots. You could see I put some details in the project information, author, client, the date, description, the venue name, and you could see that the labeled snapshot that we put in earlier comes up here, DBZ full system. It also gives what decibel scale you're using here. I didn't put notes in for the snapshots, but you could do that as well. It'll pop up down here for each individual picture. So let's scroll down. It shows all our snapshots. This is the frequency response of the microphones. You can see we have the 3 microphones that we labeled in an earlier video. Here's the speaker list, and it shows us everything that we're using. So this is the speaker deployment report. This will show the position of the speaker, how many pounds the load is, how many feet above the ground it is, gain, delay, what preset the box is, and the name of the speaker that we're using, that we used in the project. And here in the mechanical report, it'll give you actual dimensions on different angles. It'll give you what type of model you're using and what type of flybar that you'll need. Here are the subs. And that's it.